All right, we've talked about graphing exponential functions. We're going to do one more example in 12.2. What do you think is going to happen to the graph if I have the exponential function f of x equals 2 to the x minus 3? Now we've graphed 2 to the x, and we've graphed 2 to the x with a plus 3 in the back. But what do you think this number that's inside with the x up in that exponent, what do you think that number does to our exponential graph? Let's see if you're right. Let's go ahead and do another table of values, plugging in our x values, finding our y values, so that we can graph this and see if your guess is correct. Let's plug in 0. I don't know why I just started with 0. If I plug in 0, I have 2 to the 0 minus 3. 0 minus 3 is negative 3. I can make that exponent positive. I can evaluate and say I have 1/8 or 1.25. Let's plug in 1. If I plug in 1, I have 2 to the 1 minus 3, which is negative 2. I can make it positive. I can simplify, and I end up getting 1/4 or 0.25. When I plugged in 3, 3 minus 3 is 0. 2 to the 0, anything to the 0 is 1. And then I did negative 1. 2 to the negative 1 minus 3. Negative 1 minus 3 is negative 4. I can make that exponent positive by dropping it down. I have 1 over 16, which is 0.0625. You can go ahead and do the positive value, or I did the positive values. You could do 5, you could do negative 5, finish filling out the rest of the chart, and then let's go ahead and graph these points so we can see what happens to our graph. All right, finishing the chart, hopefully your values match my values, and let's go ahead and graph this and see what happens. I have a point at negative 5, 0.0039. That's a really close number to 0, right? So I have negative 5 and then just above 0. I have negative 3 and then again a really small decimal but a little bit above 0. So negative 3 a little bit above 0. I have negative 1, 0.0625, so we're getting bigger, but still a small y value. I have negative 1 and then a little bit bigger, but really close to 0 still. I have 0, 0.125. I have 1, 0.25. That's a quarter, right? 1/4, so 1, a quarter. I have 3, 1. I have 5, 4. And if you were to keep going with your x values and y values, your function would look something like this. So has that changed? Well, let's focus on kind of where it changes and it kind of starts to shoot up, right? That little changing point right there. That's that point 3, 1. Let's go back to my original graph. And where is that point at here? Well, that point's at 0, 1. And where did we end up on the other graph? 3, 1. So what's the difference there? Well, it looks like the difference is it's now shifted my graph to the right 1, 2, 3 times. Was that your guess? The number on the inside with your x shifts your graph left or right, but opposite of what you think. Kind of like a quadratic, right? And so we have a horizontal shift for that value inside. That's kind of opposite of what the sign is. And so if it were a positive 3, then I really am going to shift my function to the left 3. But now that it's a negative 3, I'm really going to shift my function to the right 3. So just like quadratics, if I have a number inside with the x in my exponent, it's a horizontal shift. If I have a number added or subtracted to my function, it's a vertical shift, shifting that up or down. Remember, if your base is a whole number, then we know it's exponential growth, so it should kind of shoot up to the right. And if it is a fraction or a decimal less than 1, then I know it's going to be an exponential decay. It's going to kind of shoot down to the right. So you should be able to look at those values and kind of figure out, sketch a rough sketch of your exponential functions.